Hey all, so this is our last section for the factoring chapter, and in this section we are going to use factoring as the first of our methods for solving quadratic equations. We'll get some more in the next chapter. But in this chapter we're going to only work with equations that will factor. In the next one we'll work with ones that don't factor. We'll have to bust out the quadratic formula. And pretty much the last 5 sections is all the heavy lifting to do this one. You can tell them apart because in the last 5, the directions were factored completely. In this one, they're going to say solve, and they're going to be, instead of expressions without equal signs, they're going to be equations with equal signs. So that means we're trying to get down to m equals some values. So let's take a look. Our first step on factoring, using factoring as a method for solving, is we want to get everything over to one side and get it equal to 0. So kind of how like this one looks. So for this one right here, I'll subtract over the 10m, and I'll subtract over the 24, and that's going to give me m squared, then minus 10m minus 24 equals 0. And this is what's called standard form. And once I'm in standard form, now I go through and I figure out which of my factoring methods I'm going to apply. So this has 3 terms. It leads with the 1, so that means it's the friendly kind where we just set up our parentheses and ask what multiplies to negative 24 and adds to be negative 10. So in that case, that would be negative 12 and positive 2 multiplied to be negative 24 and then add to be negative 10. In case anyone out there is thinking 4 and 6, if they were both negative, they would be a positive 24, so that's why that pair doesn't work. From here, we're saying something times something equals 0, so that can only be true if one of these is 0. So to figure out what that would be, I can literally just set it to 0. M minus 12 equals 0, add the 12 over, and m equals 12. If I do the same thing here, m plus 2 equals 0, subtract the 2 over, m equals negative 2. So you can see if m was 12 and I put that here, I'd get 12 minus 12 is 0 times 14, but 0 times 14 is 0. Likewise, if I put the negative 2 in here, I would get minus 14 times what would be 0, still equals 0. Easier way to do than what I just did all these steps. If it's m minus 12 as the factor, then positive 12 is going to be the 0, right? Because the factor has to have the opposite sign from when I added over. Likewise, m plus 2 is the factor, so negative 2 would be the 0. So you certainly don't need to show this, but that's why it is. This next example has 2 terms and it has a greatest common factor, so let's get that x pulled out of there first. And now difference of squares, and so that's our a plus b, a minus b. So that will be x plus 7, and x minus 7. So you notice when there's m squared on this one, I ended up with 2 m's to solve for, so I got 2 answers. This one is an x cubed, and I have 3 distinct x's, so I will have 3 answers. This first one is the too easy it's hard. It's just x equals 0. Because if you set x equals 0, you're literally saying x equals 0. If this had been 27x in front of all this mess, it's still just x equals 0 anytime you see the variable out front. For this one, it's x plus 7, so that means I would have minus 7 as a solution, or 0. X minus 7, that means I would have positive 7 as a solution. So that's my 3 answers. This one, so we got a trinomial. Does not have a common factor because this is 5s only and that doesn't go into 36. But if you notice, 25 and 36 are perfect squares, and so that means we can just factor this using the formula, and so it's going to be 25x squared would break down to 5x, and then 36 would be 6 times 6, so that would be a 6 quantity squared equals 0. And again, if you want to check that middle term, 5 times 6 is 30, and double it, and that's the 60 that it should be. This is our first one where there's a coefficient on the x. So let me just show you what that would look like. 5x minus 6 equals 0. And if I solve this out, I would add the 6 over. I would get 5x equals 6, divide both sides by 5, and x equals 6/5. So when we have these, that's where we get fractional answers. And that would be our only answer, right? Because this is really 5x minus 6, 5x minus 6. So that's our only solution. This one, let's rewrite this with, I'm going to bring these over to this side because that will keep that squared term positive. So for a second, let me write that as 3p squared plus 5p, and then it'll be a minus p squared. I'll collect terms in a second, and bringing this over will be minus 12 equals 0. So 3p squared minus p squared would leave 2p squared plus 5p minus 12 equals 0. So 3 terms, there is no common factor. There are not squares on the ends, so this means I have to use AC method. So we'll do 2 times negative 12. That's negative 24, so I need 2 numbers that multiply to negative 24 and add to be 5. So that sounds like 8 and negative 3 would add to be the 5 and then multiply to be negative 24. And then remember, for these, we rewrite those with 4 terms. So 12p squared plus 8p, and then minus 3p minus 12 equals 0. I can take 2p out of each of those first 2 terms, and negative 3 out of those next 2. And again, that's going to leave me another p plus 4. If you're questioning factoring that negative out, just distribute back and double check yourself and make sure it's what it should be. And remember, these do have to match for this method to work. So we can take p plus 4 out front, and 2p minus 3 equals 0. So our 2 solutions are going to be p equals negative 4 for that one. And then this one, if we solve just like that, you're going to get the 3 would come over and become positive, and you're dividing the 2. So negative 4 and 3/2. And then this last one here is kind of the same idea. We still have to get it equal to 0, so here I'll go ahead and multiply through that x. That's going to give me x squared plus 9x equals negative 8. And I'll bring the 8 over. And now I'm in standard form. So even though this felt kind of factored, it didn't equal 0, and I can only solve these when they equal 0 because I need to do something times something equals 0. So I need 2 numbers that multiply to 8, add to be 9. Sounds like 1 and 8. So x plus 1 and x plus 8 equals 0. And then that means that x will equal negative 1 or negative 8. And that is solving by factoring. Like I said, when we get to chapter 8, we're going to need a couple more methods for solving quadratics.